This presentation will cover how to submit multiple jobs using the HTCondor scheduler. It is appropriate for anyone who is using HTCondor to submit jobs and for anyone who is helping to support end users submitting jobs using HTCondor. So before we dive into how to submit multiple jobs, I want to take a moment to discuss why you might need to submit multiple jobs, because it turns out that how you submit multiple jobs using HTCondor will depend on your particular problem and what it looks like. So I'd like to present 3 research examples of people who need to submit multiple jobs. The first one is May Monte Carlo, and she's running particle simulations, and she needs to run many of them, and they're essentially randomized. We have Tamara Trials. So she's working on a project to design clinical trials for medicine and can change different parameters of the trial design and wants to simulate different combinations of those parameters. And finally, we have Ben Bioinformatics, and he has 20 RNA data samples that he wants to run through a standard quality control processing pipeline. So you can see that there's a wide variety of problems that might need to submit multiple jobs, and so we'll come back to these 3 examples later to see which HTCondor option is best for each person. But to get there, we'll have to talk about what they have in common, which is wanting to submit multiple jobs and how to do that. And specifically, one of our goals in submitting multiple jobs with HTCondor is that we want to avoid starting each job or calculation manually or creating separate submit files for each job that needs to be submitted. So we don't have to do these things if we're using HTCondor. This is where HTCondor really shines as a job scheduler. It has excellent first-class capabilities for submitting many independent jobs from a single submit file. First, let's review quickly what a basic submit file must look like. So this is a few standard submit file options running a sort of generic job that has an input file and an output file and is run through some script. So the executable and the arguments options in the submit file capture the components of the command we want HTCondor to run. And so here we see that in the top of the submit file. We also tell HTCondor the files we need, the input, in this case, the input file and the executable, shown in these 2 lines. And in this example, I also included the Condor options to track information about the job in a log file and the standard output and standard error files. So this is a sample submit file to run one job. And we're going to move into our first example where, say, we want to run this sample job, but we have several input files as shown here, and we want to run one job per input file. So the first thing we need to do is provide Condor with a list of the different inputs we want to use. And in this case, because our input files are numbered, that's basically going to be a list of integers, 0 through 4. The way to do this in HTCondor is to use what we call the QN syntax, where the Q keyword at the end of the submit file has a number after it, and that number will generate that many jobs, and they'll be indexed with the integers 0 through n-1, so in this case 0 through 4. So that generates our list of input values in this case. Now we need to change the top half of the submit file to be more like a template that can be filled in with the different input values. And to do that, we first need to identify which components of the submit file, which components of the job are going to vary and be different for the different inputs. And that'll be our arguments to our command and the input file that we transfer with the job. We may also want to differentiate the names of the log, standard output, and standard error files to keep those separate. And so what we'll do is we'll take these different submit file components that need to be different for each job, and we will put in a variable that will be different for each job. And when using the QN syntax, the variable that represents those integer values is called proc ID, or short for process ID. And so here we've put it in everywhere we want to insert those integer values that will be unique to each job. And this will run 5 jobs. Each one will have a different integer value and therefore a different input, and we've achieved our goal for this example. Now, you may have a situation where your inputs are not integers, but they're named. So we're going to look at a second example where we have named, not numbered input files. So we've sort of put together this theoretical program, compare states, that analyzes data from a particular state in the US. And in some ways, very similar to the previous example, we have a command that takes an input and output argument, and we have a few input files. And so this is shown in the submit file below. You can see our command in the executable and the arguments, and our list of inputs in transfer input files. And this would be what we would submit for one job, analyzing one state's data. As in the previous example, we probably have several input files that we want to analyze, one input file per job. And so again, we need to be able to provide HTCondor with a list of these different input file names. And so this time, we're going to do that using the Q from syntax. So you can see at the bottom of the submit file, I have my Q keyword, and then I've added the from keyword, and then the name of a file, and that's the contents of the file, or the box on the right. And in that file, I've put my list of different input values. So I'm going to provide my list of inputs in that separate file and reference it in the from statement. And now I need to modify the top part of the submit file to reflect the components that are going to change, the job components that are going to change per job. And so similar to before, my input and output arguments are going to be different for each job, and the input file that I transfer is going to be different. I'm going to replace these with variables, and as we've seen before, the $ parentheses notation indicates that this is a variable, and instead of proc ID, process ID, I get to choose my own variable, which is indicated in the Q statement. I've inserted my choice of variable between Q and from, very similar to writing a for loop for those who are familiar with that syntax. And then I've used that variable name in the appropriate places in the top part of the submit file to reflect what needs to change for each job. So this will now submit 5 jobs, one for each input file, and the correct information will be passed to the different job instances. As a side note, this Q from syntax is really flexible if you have pairs or triples or several input values that are going to change for each job, you can simply make a list of all the different combinations that you would like to try in a separate file, and then use multiple variables, one for each item that you're trying to vary. And then you can use those different variable names appropriately in the top of the submit file. So here I'm using a variant of my compare states program that takes not just a state input file, but a year. I've created a list of all the combinations I want to run and provided two variables, state and year, and inserted them in the appropriate place in the top part of the submit file. So this table summarizes all of the different options you can use with Q, the Q keyword, to submit multiple jobs. So the first line is the first one we saw, QN, where the list of values will be a list of integers, and there's a default variable name, procID. The other three are more, you see Q from here, allow you to provide your own list of values and your own variable name. The main difference between the three is how you provide the list of values. We've already seen Q from at the bottom, where you provide the list of values in a separate text file. But you can also provide values directly in the submit file in parentheses if you use the QIN syntax. And you could provide a list of values by creating a pattern wildcard matching using the Q matching syntax. So all ways to provide a list of values, and just differs in how you're doing that. So these four options have their own additional features. If you use QN, the default is to start at 0, but you can do a little submit file magic shown here to increment that value to start at 1. There's a little function you can use if you'd like your procID to have a certain number of digits. And so that's also shown here, and ways to customize how those numbers appear. And then for Q in, from, and matching, there's an option where you can add a number before your variable name to submit multiple jobs per item in your list. So if, for example, in this example, I had 5 data files matching this pattern, I would submit 10 jobs per data file, so 50 total, and each group of 10 jobs is indexed by the step variable, which you can see here, and that would go 0 through 9 for the first set, and then 0 through 9 again, as a way of tracking those values. Specifically for Q matching, you can refine what files or directories match the pattern you provide by using these files or DIRs keyword to return only one or the other of those types. Okay, so we've seen several examples of how to submit multiple jobs in HTCondor now. Let's return to our researchers from the beginning of this presentation. So here's our friend May Monte Carlo, and her jobs don't really vary a lot. There's randomization built into her code, so she really just needs to run a lot of basically the same simulation and get all the results and combine them. So for her, using QN is probably a good solution. It's simple, built in, no need for specific input values. She can use the procID to label all her outputs to make sure they have unique names, and then that will be it. So that should work well for her use case. Now let's look at Tamara. So suppose she has 5 different parameters that she can vary in her clinical trial design, and they're given as arguments to the program she's using. So there's no input files. She just needs to provide the 5 values as arguments, and she wants to try many different combinations. For her, Q from is probably a good option because it can accommodate multiple combinations of values per job. She could create, say, a CSV file or spreadsheet with all the different combinations she wants to try, one combination per row, and use that to submit her jobs. It'll also be easier for her to rerun specific combinations that fail. If she uses that structure, she can create a subset of the original list of options, and it becomes really easy to rerun any that need to be rerun. Finally, we have our friend Ben, Bioinformatics, and his setup is that he has one folder for each sample he wants to analyze, and in that folder he has the 2 data files for that sample. And the folders are named with a specific pattern, as are the data files inside. So because of this, Q matching would be a good option for him if his folders and input files have standard prefixes or suffixes. It's easy to pattern match. A good alternative, if he wants a bit more control and wants to be able to construct maybe paths out of the folder and file names, would be to use Q from and provide those values in a list. In his case, he's thinking ahead and also wants his output to return to the appropriate folder. So for each sample, the output for that sample to come back to the same folder where the input files are, and we'll talk about that in just a second. But first, this table summarizes some of the pros and cons that you might consider when deciding which Q option is best for your jobs. And so I won't go into this in detail, but this is a good place to pause or come back to if you're creating a new job submission and want to look at the options and which one would be best for you. The last section of this presentation isn't exactly about submitting multiple jobs, but it's about something that becomes very relevant when you start submitting lots of jobs at once, and that's organization. If you, for example, submitted 1,000 jobs and everything in the submit file was set to just go into the same submission directory, you could easily end up with over 5,000 files without really trying very hard. And that makes it hard to work and find your actual results. So it's important to start thinking about this and taking some organizational measures before you get too far into submitting multiple jobs. So we'll present a few options for doing this over the next few slides. So first, subdirectories are definitely your friends. You want to have some kind of structure. The submit file, a lot of its options, including transfer input files, log, output, and error, can use paths. So you can direct, say, the log or standard out or standard error files into their own subdirectories. You can put input files in their own subdirectory. And then a trick we're showing here is that any files, for example, that are common to all your jobs, you can put into a folder and then tell Condor to transfer the contents of that folder by listing it by name with a slash at the end. And so this syntax will transfer all the contents of that folder so you don't have to list them out by name if they're needed by all the jobs. Another paradigm that you can use for organizing job submissions and job files is one directory per job. So this is common often if people have many output files that are being generated per job that they all want to come back to the same place. So here I've set up an example where I have a directory for each job I want to run. I've happened to index them with integers so I can use the QN syntax to create my list of directories, which is going to be basically my input values. And then I've used the initialdir submit file option to tell HTCondor that it should use these individual folders as the submission directories. One for each job is how it's going to turn out. And finally, it's not always clear to people that you can use variables outside of the queue statement as well. So in this example, I've used qn to generate my list of values. So I'm going to use the list of integers to create my jobs. But I want to use the proc ID value to create the in-file and out-file options you see at the very top. And then I can use the in-file and out-file strings as variables in my submit file, replacing my arguments in my transfer input files and so on. So I don't have to write out that full file name with the proc ID variable every time I want to use it. And then finally, this example shows how you can move an output file from the main submission directory into a subfolder using the transfer output remaps option, where you give the name of the file, or in this case I've used my variable, and then equals, and then wherever you'd like it to go. So I'm moving it into a folder called output, and then again the name of the output file because it's being renamed. This works a lot like the move command in Unix. So that's all my examples. If you'd like some more resources on how to submit multiple jobs using HTCondor, you can see this GitHub repository, which has some examples based on the examples earlier in this presentation. The official Condor, HTCondor documentation has some information about this in the Condor Submit manual page. And there are 2 talks from the 2019 HTCondor Week that have some of this same material or talk about more advanced job submission features.